47% of CNCF projects saw their commit velocity drop in 2025, and that's actually good news for your infrastructure.
Wait, how is declining activity a positive signal? That sounds like projects dying. So we're breaking down which projects are consolidating, why Backstage exploded, and what these patterns mean for 2026.
By minute 4, you'll know exactly which CNCF projects to invest in and which to avoid. Let's get into it.
Welcome to the Platform Engineering Playbook Daily Podcast. Today's news and a deep dive to help you stay ahead in platform engineering.
Today, we're diving into what CNCF project velocity in 2025 reveals about cloud native's future.
Stick around to the end for today's headlines. Let's dive right in.
So let's talk about what CNCF project velocity data is telling us about where cloud native is headed in 2025. Because after 10 years of this ecosystem evolving, we're seeing some fascinating patterns emerge that every platform engineer needs to understand.
Right, and what struck me about the latest data is how dramatically the landscape has shifted. I mean, we've gone from just Kubernetes in 2016 to over 180 projects now. That's a lot to keep track of.
It is, and that's exactly why these velocity metrics matter so much. We're looking at commit frequency, contributor growth, community expansion. These are the real signals that cut through the hype. And what's fascinating is that we're seeing 3 projects absolutely dominating the velocity charts right now.
Oh, I saw this data. Kubernetes is still the giant, but Backstage more than doubled its contributions since last year. That's insane growth.
Exactly. And here's what's really interesting. Backstage's explosion isn't happening in isolation. It's directly tied to this massive shift we're seeing toward platform engineering as a discipline. Organizations are finally realizing that developer experience isn't just a nice to have, it's a competitive advantage.
But wait, let's back up for our listeners who might not be familiar with project velocity. What exactly are we measuring here?
Great question. So CNCF uses these bubble charts. Imagine 3 dimensions of data visualized at once. The bubble size represents the number of contributors, the y-axis shows pull requests and issues, and the x-axis tracks commits. It's plotted on a log scale because the differences between projects are massive.
And this gives us a real-time view of where the community energy is flowing.
Precisely. And here's where it gets really interesting. OpenTelemetry, which is now the second largest CNCF project, saw a 39% rise in commits and grew from 1,301 to 1,756 contributors in just 1 year. That's a 35% increase in people actively building this thing.
Okay, but here's my concern. Are we just chasing shiny objects? I mean, newer projects might have more commits simply because they're still figuring things out, while mature projects like etcd or core DNS are stable.
That's a critical point, and it's why we need to look beyond just raw numbers. What we're really tracking is sustained momentum combined with real-world adoption, and that's where the AI angle becomes crucial to the story.
How so?
Well, think about what's happening right now. Every organization is trying to figure out how to run AI workloads at scale. And guess what? They're not building new infrastructure from scratch. They're adapting cloud-native tools. Kubernetes is becoming the de facto platform for AI training and inference.
Oh, and that explains why we're seeing projects like Kubeflow and Crossplane gaining so much traction.
Exactly. And with the new Kubernetes AI conformance program and dynamic resource allocation features, we're seeing the entire ecosystem pivot to support these workloads. But here's the thing. AI workloads are fundamentally different from traditional microservices.
Right, they're way more resource intensive, they have different scaling patterns.
And they're creating unprecedented demands for observability, which brings us back to why OpenTelemetry's growth is so significant. When you're running models that cost thousands of dollars per training run, you need to know exactly what's happening at every layer of your stack. Coming up, we'll dig into exactly how these velocity trends are reshaping platform engineering strategies and what it means for teams trying to navigate this increasingly complex ecosystem.
So let's dig deeper into these velocity metrics, because I'm looking at this data and Kubernetes has what, over 3,000 contributors?
3,247 to be exact, with over 88,000 commits in the latest measurement period. But here's what's really telling. Despite being nearly a decade old, Kubernetes isn't slowing down. The velocity is actually increasing, especially in areas related to AI workload management.
That's fascinating, because you'd expect a mature project to plateau.
Right? But what we're seeing is Kubernetes evolving into something much bigger than just a container orchestrator. It's becoming the operating system for AI. The dynamic resource allocation feature that landed in 1.34, that's specifically designed for GPU scheduling, which is critical for AI workloads.
Okay, but let's talk about Backstage for a minute. A doubling of contributions? That's not normal growth, that's explosive. What's driving this?
It's the perfect storm of factors. First, you have the platform engineering movement hitting critical mass. IDC estimates that by 2026, 80% of large enterprises will have dedicated platform teams. Second, Backstage solves a real pain point, developer portal sprawl. Most organizations have dozens of tools, wikis, and systems that developers need to navigate.
But isn't Backstage just another portal that adds to the complexity?
That's the beauty of it. It's not just a portal, it's a framework for building your internal developer platform. Spotify designed it to be extensible through plugins. So instead of replacing your tools, it becomes the single pane of glass that integrates them all.
Oh, I see. So companies like American Airlines, Expedia, and HP are using it to create these unified developer experiences.
Exactly. And here's a specific example. American Airlines reported that after implementing Backstage, they reduced the time to provision new services from days to minutes. That's not just efficiency, that's transformational for developer velocity.
Now, OpenTelemetry's growth, 39% increase in commits, that seems directly tied to the complexity we're adding to our systems, right?
Absolutely. And it's not just about having more services. AI workloads introduce new observability challenges. You're not just tracking HTTP requests anymore, you're monitoring GPU utilization, model inference times, token usage, memory patterns that can make or break your costs.
Speaking of costs, that's something we haven't touched on. These AI workloads are expensive.
Incredibly expensive. We're talking about organizations spending millions on compute. And here's where OpenTelemetry becomes critical. It's vendor neutral. You can instrument once and send your telemetry data anywhere. No vendor lock-in when you're trying to optimize costs across multiple clouds.
That vendor neutrality seems to be a common thread across all these high-velocity projects.
Bingo. That's the CNCF superpower. These aren't vendor-controlled projects. Kubernetes has contributors from Google, Microsoft, Red Hat, Amazon, even competing companies collaborate because the rising tide lifts all boats.
But here's what worries me. We have 180 plus projects in CNCF now. How do platform teams even begin to navigate this ecosystem?
That's the paradox of choice problem. And honestly, it's why velocity metrics matter but aren't the whole story. You need to look at graduation status, production adoption, and most importantly, whether a project solves your specific problems.
Can we talk about some of the projects that aren't showing high velocity but are still critical?
Great point. Take etcd. It's not topping any velocity charts, but it's the distributed key value store that makes Kubernetes possible. Or Prometheus. It's mature, stable, and running in production everywhere. Low velocity can actually be a sign of stability.
So velocity indicates where innovation is happening, not necessarily what you should adopt today.
Exactly. It's about understanding the trajectory of the ecosystem. High-velocity projects like Cilium, Flux, and Argo are solving emerging problems around networking, GitOps, and continuous delivery. They're where the ecosystem is heading, not necessarily where it is today.
And what about the AI-specific projects? Are we seeing new ones emerge?
We are, but what's more interesting is how existing projects are adapting. Kubeflow for ML workflows, Crossplane for infrastructure composition, even service meshes like Istio are adding features specifically for AI traffic patterns. The ecosystem is evolving rather than fragmenting. Stick around, we'll give you the exact framework for evaluating these projects and building your platform engineering strategy around what actually matters.
All right, so for platform engineers listening to this, how do we actually use this velocity data to make decisions?
Here's the framework I recommend. First, separate your infrastructure into 3 categories: foundational, differentiating, and experimental. Foundational is where you want boring, stable technology. That's your Kubernetes, etcd, Prometheus tier.
So high velocity isn't always good for foundational stuff.
Exactly. For foundational infrastructure, you want graduated CNCF projects with years of production usage. Now, for differentiating capabilities, that's where velocity metrics become more relevant. If you're building a platform that gives your developers a competitive edge, you want to look at high-velocity projects that are solving emerging problems.
Like Backstage for developer experience or OpenTelemetry for observability.
Precisely. And then experimental is where you can take more risks. Maybe you pilot Crossplane for infrastructure as code, or try out Dapper for microservices. High velocity here might indicate innovation worth exploring.
What about the AI angle? How should teams prepare their platforms for these workloads?
This is critical. Start by ensuring your Kubernetes clusters support GPU scheduling. Look into the dynamic resource allocation features. But more importantly, instrument everything with OpenTelemetry from day one. AI workloads will blow your budget if you can't see where resources are going.
That sounds like a lot of change at once.
It is, which is why I recommend a phased approach. Phase 1, establish your platform baseline with graduated CNCF projects. Phase 2, add developer experience improvements with tools like Backstage. Phase 3, optimize for AI workloads with advanced scheduling and observability.
What about organizations that are already deep into their cloud-native journey?
For them, it's about consolidation and optimization. If you've got 50 different tools, Backstage might help unify that experience. If you're struggling with costs, OpenTelemetry can help you understand where money is being wasted. The velocity data shows where the community is investing in solving these exact problems.
So we should be watching velocity trends, not just current snapshots.
Yes, look at the trajectory. OpenTelemetry's 35% year-over-year contributor growth tells you that observability is becoming even more critical. Backstage doubling its contributions signals that platform engineering is hitting mainstream adoption.
What should we be watching for in 2025 and beyond?
3 things. First, watch for AI-native projects entering CNCF. We'll likely see specialized tools for model serving, feature stores, and ML observability. Second, expect consolidation in some areas. We probably don't need 15 different service mesh projects. Third, developer experience will become the primary differentiator.
That last one, isn't developer experience kind of fuzzy?
It used to be, but now we can measure it. How long does it take to provision a new service, deploy to production, debug an issue? Platform teams that can quantify and improve these metrics will justify their existence and budget.
And that's where tools like Backstage come in. They make these workflows measurable and optimizable.
Exactly. Here's my practical advice for listeners. Start by auditing your current platform against these velocity trends. Where are you using projects with declining momentum? Where could high-velocity projects solve real problems? But always filter through your actual needs, not just what's trending.
Any final thoughts on navigating this 180-plus project ecosystem?
Remember that CNCF's growth from one project to 180 isn't fragmentation, it's specialization. We're seeing the Unix philosophy play out at cloud scale. Small, focused tools that do one thing well, composed into powerful platforms.
So the skill isn't knowing all 180 projects, it's knowing how to evaluate and compose them.
Precisely. And here's the thing that the velocity data really reveals. Cloud native isn't slowing down. If anything, it's accelerating. The intersection with AI is creating new challenges that the community is actively solving. Platform engineers who understand these trends and can navigate this ecosystem effectively will be the ones building the infrastructure that powers the next decade of innovation.
And that open, collaborative approach is what makes this ecosystem so powerful.
It really is. Every contribution matters, whether it's code, documentation, or just helping someone debug an issue. That's 1,756 people making OpenTelemetry better, 2,347 improving Kubernetes. This velocity data isn't just numbers, it's the collective effort of our entire industry building the future together. Before we wrap up, let's catch up on this week's infrastructure news. There's a fascinating new development in the world of DevOps automation. Harness just published an article about agentic AI that's really pushing the boundaries of what we thought was possible with autonomous infrastructure.
Agentic AI? That sounds like we're moving beyond just automation scripts and into actual decision-making systems.
Exactly. They're introducing this CPA model, context, planning, and action, where AI agents don't just execute predefined tasks, but actually understand the environment and make intelligent decisions about infrastructure management.
That's a huge leap from where we are today. Are we really ready to hand over that much control to AI?
Speaking of AI transforming infrastructure, TiDB is making waves with what they're calling AI-native databases. According to the new stack, they're arguing that traditional databases just can't keep up with AI workloads anymore.
Oh, I've been following this trend. The shift from human-centric data consumption to AI-centric is massive. These databases need to handle vector embeddings, real-time processing, and massive scale all at once.
And TiDB claims they're built from the ground up for this. It's not just about storing data anymore, it's about making it instantly accessible for AI models.
Meanwhile, Data Intensity is partnering with GitLab to offer DevSecOps as a service on Oracle Cloud Infrastructure. This caught my attention because it's specifically for GitLab's self-managed instances.
Right, they're trying to give enterprises the control of self-managed GitLab, but with the ease of a managed service. Best of both worlds approach.
And here's something interesting. Ex-Googlers just secured $10 million for Infinimind, a startup that's tackling the video data problem.
Video data problem?
Think about all the surveillance footage, meeting recordings, and operational videos companies have. Infinimind is building infrastructure to convert all that unviewed content into structured, queryable business data. TechCrunch reports they're essentially making video as searchable as text.
Now for some software releases. Portainer just dropped version 2.33.7 LTS, and this is a security release platform engineers should pay attention to.
What are the key fixes?
They've addressed issues with the Update Stack button not responding, containers page failing to load, and errors when updating edge stacks. But heads up, there are still some known issues with Podman support, especially around auto onboarding.
And Pulumi released version 3.220.0 with some interesting features. They're now using the Pulumi Cloud Registry by default for package resolution, which should streamline workflows.
The big addition is the env-var mappings resource option for provider resources. This lets you remap environment variables before they're passed to providers. Super useful for complex deployments. Plus, they've added better debugging with environment variable display during snapshot integrity errors.
That wraps up today's news.
That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
And check out platformengineeringplaybook.com for more resources and guides.
Until next time.